好，各位下午好，欢迎大家来参加由台北当代艺术馆主办，由孙艺珍策展人所策展的艺术家面对面活动。我们称这个活动为“如果意识能同在”。
Thank you everyone for joining this session prepared by MoCA and prepared by our curators Ying-Tung, and thank you everyone to be online.
那我是阳明交通大学心智哲学研究所林映彤，担任今天的主持人。
I am Professor Ying-Tung from the Yangming Jiaotong University's Institute of Philosophy and of Mind and Cognition.
这场座谈或者是分享邀请了2位艺术家，一位是Špela Petrič， 另一位是 Guy Ben-Ary。
Today we have 2 artists with us. One is Špela Petrič and also Guy Ben-Ary.
他们的作品目前正在台北当代艺术馆共视觉的展览中展出。
Their works are now exhibited in Taipei, in MoCA TAIPEI, in the exhibition titled "The Proto-ocean for Co-consciousness."
也许各位朋友已经在现场看过作品了，带了很多问题跟想法来参加，也或许有些朋友还没有看过作品，所以在听完今天艺术家本人的分享之后呢，可以再去现场看，会更有感觉。
Some of you have already seen the works in the exhibitions, and maybe you have some questions in your minds. And if some people haven't watched the exhibition yet, I hope that after the discussions, we can trigger your interest to go to the exhibition.
待会我们的进行方式会是先由 Špela 来跟大家分享，那接下来是 Guy。
Later on, we'll start with Špela and followed by Guy.
那先让我来介绍一下今天的艺术家。第一位是 Špela Petrič， 那他是斯洛维尼亚的新媒体艺术家，那他有自然科学的背景，他是有生物学的 PhD。
First of all, let me introduce Špela. Špela is a new media artist based in Amsterdam now, and who has natural science backgrounds with a PhD in biology.
他的创作结合了自然科学、表演还有生物媒材，然后借由某些跨物种的结合或者是互动来检视人类中心主义的局限。
So her practices combine the natural sciences, biomedia practices, performances, and to examine the limits of human centers and also multi-species endeavors.
那也可以把他的作品当作是探索我们生物科技社会的一些本体或是知识论问题的一个艺术的实验。
It's also experiments and studies regarding to ontologicals and also ethnological and underpinnings of our technological society.
那另外一位艺术家呢是Guy Ben-Ary。
Today we also have Guy Ben-Ary with us.
那他是驻澳洲博斯的艺术家跟研究者，他目前在西澳大利亚大学的艺术实验室 Symbiotic 工作。
He's an Australian artist and researcher based in Perth, is now working in West Australian universities in a artistic laboratory called Symbiotic App.
那Guy的研究领域包含了cybernetics 系统控制，或者是还有软式机器人 soft robotics， 还有生物科技。然后他的作品常常会受到科学跟自然的启发。那这次要介绍的作品 cellF 也是其中一个。
So he works on cybernetics, so some robotics, and also cultural articulations of biotechnologies. Today, he will present the work cellF in MoCA.
那废话不多说，我们就先请Špela 来介绍他的作品 Play。
Without further ado, Špela, the floor is yours.
Thank you very much. So today I will present a little bit of my artistic practice, ending with a bit of more in-depth explanation of Play, which is the work that is on show in MoCA.
今天会跟各位介绍我的艺术实践，同时呢，会也就跟各位分享一下我现在目前在台北当代艺术馆所展出的 Play 这件作品。
Okay, first slide, please. So I'd like to start with this picture, which displays sort of the motivation between for my work with plants. Clearly here, most people would say that what is pictured is a rabbit. However, the rabbit is actually standing behind the grass. So this demonstrates plant blindness that oftentimes just prevents us from seeing plants.
我一开始想先给各位看这张图片，那一般的是这个是我自己想要去研究植物的动机。各位看到这张图片的时候，通常的人会先注意到那只兔子，但其实呢，这只兔子是站在草的后面，或者站在植物的后面。换言之，一般人很多时候会对于植物视而不见。
So about 7 years ago, I started an artistic journey to try to explore what is behind this plant blindness. Why we disregard these really important creatures and kind of commit them to being in the background, and how to possibly change this relationship.
我从7年前开始进行艺术的探索之后，想要了解到底为什么人们会对植物这些重要的生物视而不见，为什么会非常习惯把植物放在背景，而忽略了它的重要性跟存在。
Next slide, please.
下一页。
So one of the first experiments, artworks that I performed was called Scotopoiesis. And it was an attempt to communicate with cress in plant time.
各位看到，这是我当时第一件的艺术作品，叫做 Proto-ocean。在这个作品当中的时候，我要去希望看到的是人跟植物的关系，还有在时间的关系。
So to do this, I had to commit to stillness for an extended amount of time, namely for 20 hours, casting a shadow onto the cress.
各位看到，我当时的设计是我必须要站在这个同位置上面长期20个小时不动，站着不动之后，然后透过这样的情况之下，在草地上面呈现阴影。
Next slide, please.
下一页。
So during this process, the cress, which are these tiny plants, actually sensed the absence of light and started to grow taller and grow paler.
在这个长时间不动的情况之下，在我影子底下的这些小小的植物，它们感受到了，因为缺乏阳光，所以它们相对而言长得比较快速，但是也长得比较苍白。
Next slide, please. This is a close-up of the cress.
这看到是植物的特写。
Next slide, please. And this is the result of the intercognition. So clearly we can see sort of a silhouette of my body attesting to this effort to communicate with the cress.
各位看到，在20小时站立之后呢，草地上面出现了我的剪影的轮廓，所以可以看到我的行为的确影响了植物的生长跟变化。
But what started basically as a process of biosemiotics actually opened up a whole new dimension of plant being to me.
在这个过程当中，虽然只是一个互动的情况跟实验，但是也重新打开了植物对我的意义。
And in the following works, I was exploring how actually plants could become part of our sensorial milieu as humans. Yeah.
在后续的作品当中，也不断的探索植物如何存在在人类世界或者整个世界的重要一部分。
Next slide, please. This is an early work made in collaboration with artists and designers and architects, Ying-Tung, Dimitris Stamatis, and Yasmina Weiss.
这是我的早期作品，那在投影片的最下面看到这些名字是我们当时的合作对象。
It's called Plant Sex Consultancy, and it was about trying to create sex toys for plants.
这个作品叫做 Plant Sex Consultancy， 当时是希望能够针对植物设计出他们的性爱玩具。
Next slide, please. So we wanted to take this human-centered design and think what would happen if instead of the human, we thought about the plant, to design sex toys for them.
我们当时采用这种所谓人本设计的概念，但是当人本取代变成以植物为本的时候，如何用这样的逻辑跟原理还有概念去设计出植物的性爱玩具？
Of course, the basis of human-centered design is the interview with the client. But here, because we can't talk plant language, we actually consulted scientific articles.
因为在人本设计当中，很重要的设计的基础是透过跟客户的访谈，但是跟植物之间我们听不懂植物说的话，所以我们这个时候在这个访谈基础只能仰赖科学期刊跟论文。
So here are some sex toys or reproductive augmentations that we came up with.
所以这是我们后来设计出来的植物的性爱玩具，或者是所谓透过这样的光是让他们的感官能够扩大。
Because what is pictured here is the cyclamen, and the cyclamen has a pollinator. So the pollinator is a bee that helps it spread its pollen.
那这个的话，这设计出来的这个设计呢，其实是仿照蜜蜂的作用，还有这个授粉的授粉动物的作用。
And it does so by the bee would shake this pollen sac at the frequency of this middle C, and the pollen would drop on the back of the bee. And then that's how the bee would carry it from one cyclamen plant to another.
那一般的时候，蜜蜂是因为它在震动的时候，让花粉掉到它们的背上之后，这样的情况之下，帮助花朵传播花粉。
But the issue is that this particular bee that the cyclamen developed this tight evolutionary contact with had gone extinct. So since that point on, the cyclamen is tended to by other less optimal pollinators.
所以在这种情况之下，有时候因为这个花粉的传播过程里面并没有办法一定能够达到他们授粉的目的，所以当时他们就设计出了这个另外一种可以传播花粉的方式。
So this sex toy that we came up with is a little bit of a vibrator that actually detects any type of insect coming in the vicinity of the cyclamen flower and just shakes it at the right frequency to drop the pollen, so therefore sort of substituting this frequency of the extinct bee.
在这个情况之下，这个装置所发挥的功能就是基本上就是个振动器，它可以透过感知的方式跟感测的方式，如果有其他的昆虫接近了这个花朵的位置的时候，它们就会发出震动，让花粉能够掉下来，掉到这些的昆虫身上之后，帮助它们授粉，来继而取代这些已经灭绝的蜜蜂。
Next slide. This is, yes, another installation view. So the augmentations were really just prototypes. They're 3D prints and never really intentioned to be made into a real product. They were sort of an exercise in thinking.
这是我们当时用 3D 列印所制作出来的模型，我们用把这样的概念之后，把想法能够转化成具体的东西具象出来在各位的眼前上，但当时并没有意识或打算要把它作为真正的产品。
Next slide. I'll go a bit quickly through these. This vanity lace for the carnation was meant to prevent the spread of sexually transmitted diseases, which actually are in the plant world's fungi.
那各位看到的这个装置设计呢，是基本上希望能够去保护康乃馨，然后让它避免去散播感染到这些所谓植物当中的性病，也就是所谓的这些的菌类或菇菌类病毒。
And the fungus is, of course, spread by pollinators that are visiting flower to flower. So when you cover up of the flower, you reduce the chance of this particular plant being infected.
那这些的真菌之所以会传播呢，通常就是因为透过昆虫在不同的花丛之间传递而来的。所以如果你透过这样的装置保护花朵的话，就可以减少它们受到真菌感染的机会。
Okay, next slide, please. And finally, there's also another dimension of thinking about sex and reproduction in this case of the turmeric, we realized that human breeding has modified the plant so much that it's not able to actually reproduce sexually anymore.
在这个设计当中，我们要重新思考的是性跟生殖的关系，因为我们注意到在这个植物当中的时候，因为人的呼吸的关系影响很大，导致它们失去了生殖跟繁殖能力。
So we designed or we conceived of this human-assisted apparatus that would take the root of the turmeric and sort of we would let it go up into the sky where it would be irradiated with the UV in order to fulfill this function of sexual reproduction, which is to diversify the genome.
在这种情况下，我们想象这个好像是人工生殖的技术，人工抚育生殖的技术。我们透过这样的情况之下，把它的根，然后放到高空上面之后，让它接触到阳光，进而可以进行所谓的生殖跟繁殖的功能。
But also, finally, when the balloon pops and the root of the turmeric drops to the ground, it's actually spread very far from the mother plant.
所以当然到了高空之后，这气球会爆开，爆开之后，这根部就会重新降落，掉在地面上，而它们掉的地方可能会离原来的这个植物有很长的距离。
But from these sex toys or reproductive augmentations, you can tell also that we weren't quite able to grasp one of the key components of sex toys, which is pleasure.
当然，在这样的过程里，我们去重新想象植物的性爱玩具或者是繁殖放大功能的时候，其实缺少了很多我们在一般这个所谓性爱当中的愉悦或者是乐趣的成分。
So this is something that I will come back to in my later work, especially with the play that I'll be talking about at the end.
所以我后来在其他作品当中就试圖去專注在這個所謂玩樂的成分。
Okay, next slide, please. So after a couple of years working on plant ontologies, so to understand what makes a plant, I also started thinking about how artificial intelligence and just the algorithms could help or prevent us from understanding plant life better.
我在研究了植物多年之后呢，其实也开始去思考到底，比如说人工智慧或者是演算式能够如何帮助植物或者是影响植物的发展。
So with this, I started an opus called The Plant Machine, which would actually explore this relationship between the plant and the algorithm.
我之后就开始发展出了一套计划，叫做植物机器。在透过这样的情况之下去了解植物跟演算式之间的关系。
Now, one of the things that are really important to realize is that this isn't something that is novel in itself, because plants, after all, are one of the organisms that are most intimately associated with algorithms, and this is in agriculture.
其实在植物发展当中的时候，一直他们都跟演算式之间有很密切互动的关系。这些我们现在所知的农业就是这样出来的。
But in agriculture, the relationship is always one of utility. So the algorithms, the sensing devices, the planning is always used to optimize either fruit production, flower production, anyway, to sort of satisfy a need for a commodity for humans.
过去农业上面也运用演算式在影响植物的时候，其实主要是为了功能性的需求。他们透过演算式啊、感测器、人工智慧等等，希望还有各种不同的规划，希望能够去提高作物的产量。
So in the plant machine opus, I'm not saying that I'm satisfying non-human needs, but definitely the desires are different and not as utilitarian and more inviting playfulness and joy.
在植物机器的计划当中的时候，我们主要并不是着重在所谓功能性的考量或者是人的需求的满足，而是希望能够纳入很多这些所谓玩乐或者是其他非人类需求的层面。
The first work in this series is called Institute for Inconspicuous Languages, Reading Lips.
那这个作品呢的第一部呢叫做 Institute for Inconspicuous Can you repeat the title?
Institute for Inconspicuous Languages, Reading Lips.
Institute of Inconspicuous Lips, Reading Lips 这个作品是他们当时植物计划的第一部。
Yeah, it's a bit of a mouthful, sorry. So the premise here was that plants actually have a really interesting anatomical feature. Next slide, please.
下一页当中看到，其实植物在解剖上面会有非常特殊、非常有意思的特色。
So if you look at the leaf on the bottom side under a microscope, you will find it speckled with thousands of these small structures that look like mouths.
所以如果看到叶子背面放在显微镜底下，才会看到它们其实有非常多无数这个长得像人的嘴巴的结构。
So scientifically, these organs are called leaf pores or stomata, and they're actually used as holes in the plant body to exchange various gases.
那这些上在就是叶子背面上面的气孔，那这些气孔它其实会透过这样的这个气体排出跟吸入的方式呢，来作为作为气体交换。
But in this project, I speculated that actually the fact that they look like mouths and they function like mouths could be actually a way that we communicate with these plants.
那我当时这个作品的假设是，这些东西长得像人的嘴巴，它其实功能也可能是跟人的嘴巴一样，会有很多传达和沟通的能力。
So could you play the next slide, please?
Ma. Atimuche ga. Onde se vidi ga. Mama ga. Wow.
Next slide, please. So what we actually saw was a sped up version of the microscopic video, so a time lapse basically of the stomata moving, and a human interpreter for the deaf trying to read the lips of the plants.
可以看到当时我们拍摄的是这些气孔的缩时摄影，所以然后再由手译员透过他们的口型变化来判读说他们说了什么东西。
And that was followed by the same action performed by an open source neural network, so an AI called LipNet that also tries to read the lips.
我们后来也透过这个开源式的神经网络，这套开源式的人工智慧呢，试图读唇语。
And it's actually really interesting that LipNet, when reading human lips, is much better than any human reading lips. However, even LipNet gets it right only half of the time, because lip reading is highly contextual. It's a lot of guesswork.
这套人工智慧系统虽然它非常善于去读人类的唇语，但是他们其实在读这些植物的唇语的时候，大概正确率也只有50%左右而已。因为读唇语的时候，其实非常仰赖旁边的脉络跟背景，还有很多的推测。
So in a way, I like the slippage of meaning that happens in this project. It allows us to laugh at ourselves and our insistence on language as the vehicle for communication with non-humans, while at the same time we are actually communicating with plants through molecules all the time.
各位看到，在这个作品里面，其实我们要去反讽的是，人类非常坚持说要用透过语言的方式才能够沟通，即便是看到植物，也是依然坚持植物似乎也需要用语言来沟通。然后同时的话，我们也同时看到植物跟时间还有时间演变之间的关系。
Next slide, please. And the next project, I really wanted to explore further the relationship we have with our plants that we keep in our homes, that also seem to disappear into the background oftentimes.
我下一个作品想要去探究的是我们这跟人类居家盆栽之间的关系，因为很多时候这些居家盆栽好像也融入了一般家庭生活的背景当中。
And while reflecting on the relationship with plants and how they are produced massively, they become commodities, they are sort of living commodities. I drew a comparison actually to us people also becoming commodities in the digital realm.
在这个作品当中，我思考的是这些植物，因为在商业的需求之下呢，被大量繁殖之后，就变成活的商品来贩卖。就好像我最在思考反思的是，在数位时代里面，人本身似乎也变成了商品。
So specifically, I was focusing on how different wearables are basically reporting data from our bodies, which is somewhere being commodified, made into a product and sold back to us as advertisement, as population statistics, and so forth.
很多时候，我们人类穿戴着这些穿戴式装置呢，他们不断的收集我们人体的数据之后，传输回到中央系统之后，经过了处理跟演算之后，再变成商品卖到我们的眼前，然后变成我们购买的商品，比如说各种广告，或者是我们在人类世界当中看到的各种的数据跟资料。
So I was wondering if other than humans could also become literally these actors that produce biodata.
我也好奇这些所谓的非人是不是也能够产生出各种不一样的生物资料。
And this was the inspiration. Please show the video.
所以这就是我当时创作的背后动机，请各位看一下影片。
Americans have Fitbits and pedometers in order to track their physical activity.
But as CBS 4's Gilma Abalos reports, some people figured out how to earn steps without ever taking one.
This man isn't doing laundry. He's asked us not to show his face because of what he is doing with his company-issued step tracker.
Putting Fitbit in sock, hour and a half or no heat setting in the dryer, 11,000 steps. Thank you.
He's earning 11,000 steps without moving. As is the case for many employees, his pedometer is linked to company insurance incentives that can lower his payments.
You are now more involved in, well, how much is this bill? How many steps?
Companies benefit from a healthy workforce, and many are rewarding workers with freebies for getting fit. But there's also a growing movement online to cheat the system.
We're starting with 3,472 steps.
We were curious, do the hacks even work? So we ran our own unscientific test.
This does still take some effort on your part to sit here and press this button for a while. Okay, there's a minute. 35:41.
That equals about 70 steps.
Would you like to summarize?
Yes. 刚才看到新闻报道是在描述，现在很多美国公司为了要去促进员工的生活健康，去鼓励大家运动，然后这些的健康数据呢，有时候也能够影响你的保险的费用，所以很多人开始有不同的方式去欺骗或者是玩弄这些的健康数据的这个监测装置，比如说把它丢进干音机里面呢，或者是刚才看到的有各种不同的方式之后，仿佛你好像走了很多的步数，但其实一步都没动。
Next slide. So the idea here was to ask, this is a video, maybe you can play it. What if these, instead of people, plants were wearing these smartwatches? And so we connected these plants to sensors of electrochemical activity. Here you can see them, basically measuring electrochemical potential or their excitation. And depending on how excited they were, the drill machine would get pressed more or less. And on this drill machine is the smartwatch measuring the activity of the plant.
可以看到这个作品的设计方式是，如果把智慧手表戴在植物身上的时候，会有什么样的效果？那这个感测器呢，在植物身上的时候，会感测它们的电子化学的变化。那个化学变化反映出来是它们的兴奋程度。当它们越兴奋的时候呢，下面的这个电钻它就是动得越快，然后这个电钻上面的这个运动手表呢，就会因此记录到更多的步数。
Next slide, please. So in this way, the plants actually also become consumers in a way, because they produce the data, which is not just noise. It is a representation of another living entity. And I'm wondering how long it would take for these algorithms to figure out that this entity is actually not like the others.
各位看到我们这样的设计呢，其实是希望去了解，当植物变成消费者之后，他们的这些数据呢，转化成这些人工智慧或者是演算式所了解的数据之后，会产生什么变化？那这些演算式需要花多久的时间才会注意到这些的数值其实并不是来自于人？
It also represents one of the ways of resisting surveillance technologies with these quick and dirty hacks that happen at the level of the interface, at the level of the body.
我们也希望透过这样的方式去抵抗很多各种各式各样的监控科技，然后透过这些很简单的骇客的手段，然后去影响身体数据的收集。
Next slide, please. So now I'll just talk about the last project, which is called Play, PL apostrophe AI, standing for plant and AI, engaging in play.
各位看到这个是我们这次在当代馆所展出的作品，叫做 Play PLAI，PL 代表的是植物 ，AI 是人工智慧，然后上面有一撇代表的是两者之间进行了玩乐的动作。
So whereas in the previous projects of the plant machine, I was taking, or in collaboration, of course, with programmers and engineers, we were appropriating already existing AI programs. This one was really about asking ourselves, can we write a program? Can we make an AI robot designed to play with cucumber plants?
在刚才的两个作品当中的时候，我们都是跟城市设计师还有工程师合作，去挪用既有的人工智慧和演算式，进而去了解他们跟植物之间的互动关系。那这个作品里面，这一次展出的作品里面，在思考的是有没有可能去设计出一套程式或一套人工智慧，能够跟植物小黄瓜开始玩乐。
Next slide, please. It's a video. So, thinking about play, I believe that playing is a property of all living organisms, including plants, because it is so important to understand what a body can do, how it relates to the other phenomena in the world. And there's the motivation that this activity is joyful, it's pleasurable, and it's free.
可以看到我们的假设是玩乐是一个各种不同的有机植物或者是活体的生物他们都会想做的事情，而透过这样的过程里面他们能够跟其他旁边的这些周遭环境跟背景互相的互动，同时在里面找到快乐跟愉悦的感觉。
So play is actually quite difficult to define scientifically. There's a couple of criteria that it has to follow, but to be honest, these criteria are very anthropocentric and sometimes depends on us knowing if the entity playing has done so with its own free will, so that it is consensual.
很多时候我们对于玩乐的科学定义其实并不清楚，他们有几项科学的标准必须要符合之后才能够达到所谓科学上面的玩的定义，但这个科学上的玩的定义其实非常的以人类中心，而且我们很难去判断到底这些的玩乐的发生的时候到底是不是出于自由意志。
And this immediately limits the possibility of scientifically defining something as play when it comes to non-humans.
所以这种情况之下要去定义对于非人而言到底什么是玩乐就变得非常困难。
But for me, this ambivalence is actually very generative. It was precisely what I thought would be a good case to try the limits of AI with.
但也正是因为这样的灰色模糊不清的地带，让我正是能够认为可以透过人工智慧的方式去尝试到底植物如何玩乐。
So I think what you saw in the background was a cucumber time-lapse playing. I was manipulating the sticks manually, but it was very hard to actually interact with the tendrils of the cucumber in human time while the plant was moving in plant time.
这是各位看到的缩时摄影，这一株的小黄瓜在往上生长的时候，我就用人工手动的方式去控制旁边的这些的竹签跟竹竿，但是当然我们在去用人类的时间感去了解他们的玩乐，这是非常困难，因为植物是用植物的时间感在生活的。
So in a way, it makes sense to build a machine to help us play with cucumber plants.
所以这种情况之下，当然用机器来跟小黄瓜猪玩乐是比较容易的。
Next slide, please. How to, again, design a plant-centered AI robot. That was the challenge that we set ourselves. And basically to follow the plant growth and the plant movements, we used a lot of the sensing technology that is used in this really advanced industrialized agriculture.
在这个作品当中的挑战是，我们要如何去打造出一部的人工智慧的机器人，然后可以去感测，还有跟植物互动。在过程里面，我们当然是用了很多现在工业化农业所使用的感测器。
But most of these things we achieved by appropriating more like low-grade consumer electronics like this LiDAR scanner.
或者是我们也会使用一些比较低成本比较低廉的这些消费电子产品的感测器，比如说可以看到这是非常平价的雷射光的感测器。
Next slide, please. So here we see one of the programmers team fiddling with the scanner, so that we mounted on a trolley that would go like do this 270 degrees scan around the plant to get their three-dimensional surface image.
这是看到城市设计师他们在制作的感测器之外，还有另外一个这个他们在安装跟架设是扫描器，可以透过270度的扫描的时候得到植物的3D 影像画面。
Next slide, please. In fact, this was really like a large-scale collective effort. At the end, it was, I think, around 10 people with different backgrounds and capacities coming together to build this machine.
前后后来大概动用了10个人一起合作之后，运用各种各自的不同的专业跟能力来打造出这一部人工智慧的机器人。
Next slide, please. And this is what it finally looks like. So we can see sort of a structure that at the top holds 36 stepper motors, and each one has a metal wire that ends with a bouncy ball.
各位看到这是最后的成品的样貌，在上方的时候有36具小型的马达，那马达上面都悬吊了金属线之后，还有悬挂的一颗弹力球。
And these wires the position is controlled by the AI in actually a sort of a distributed computing system. A little bit of which you can see there as a screen that is sort of the central computer.
各位看到人工智慧是透过马达去控制这些线路还有弹力球的高低，进行了分散式的运算系统之后呢，去跟植物进行互动。
But there's also 3 other Raspberry Pis and a bunch of Arduinos that are distributed on the robot.
当然在这个机器人上面还有很多 Raspberry Pi 或者是 Arduino 的这些感测器跟运算装置在背后分散出去。
So the motors are driven and the balls are lowered and raised at plant speed, so about 3 centimeters an hour.
在这个过程当中，这些马达会用植物的速度来调整这些弹力球的高低，大概每1小时3公分左右。
And this corresponds with the plant speed.
当然也对呼应到了植物的速度。
But every 15 minutes, there's the scanner, which I showed you before, that keeps continuously scanning the surface of the cucumber plants to see the general movement.
刚才介绍过的扫描器则每15分钟会扫描一次，去观察还有记录植物的变化。
Next slide, please. This is what the time lapse of this play in action looks like. So we see the scanner continuously working and the balls approaching and going away from the tendrils of the cucumber plants.
在缩时摄影当中，各位看到扫描器定时的进行扫描，同时这些弹力球也不停的在高低变化当中，进而跟产生跟小黄瓜猪不同的互动。
Next slide, please. So I would like to just show you a little bit of the background of what actually is going on in this machine. So this is a raw image of what the scanner sees. This is the different grays represent the depth, but you can also see that the tendrils are actually not visible.
各位看到，这是在扫描器所扫描出来的原始图像，不同的色层的其实代表的是不同的高低跟不同的深度，而在过程里面，各位看，你其实看不到任何的弹力球。
So we are dealing with something that is very characteristic of basically all robots, but all of life. The sensorium is limited. So the image of the world that the robot gets is not infinitely fine.
所以各位看到，这也其实是我们人类世界所面临的情况。即便是透过机器人，我们所收集到的资讯依然是有限的，不可能无穷无尽的继续精细下去。
And this was one of the major challenges of making this robot. How can we play with cucumbers, with the tendrils of the cucumbers, when the robot doesn't even see the tendrils?
这也是我们在面临的一项挑战，在设计这个人工智慧机器人的时候，到底在 要怎么样设计可以让机器人在即使看不到这些触手的情况之下，跟这些小黄瓜猪的触手开始玩乐呢？
But this actually turned out to be not just poetic, but also really interesting because it so much reveals how robots are made to work.
其实这个过程里面也变得非常的有意思，也很有诗意。他们在思考跟分析的是，到底追根究底，当初机器人是怎么设计运作的。
Next slide, please. So there's another sensory system that consists of 6 cameras, each looking at a certain segment of this patch of cucumbers. And we can see this is a composite image of the 6 cameras. You can sort of see the borders that don't match up. That's what each camera sees.
另外一套感测系统则使用6部摄影机去拍摄这一重小黄瓜猪它们不同的位置，然后这位看到的是，这是后来影像结合拼接起来之后的面貌。
So using this specialized set of cameras and another machine vision, a neural network, the robot is able to discern if a tendril has wrapped around a ball.
在这样的系统跟摄影系统和机器视觉的辅助之下，机器人和人工智慧就能够去看到小黄瓜猪的触手是不是已经绑住了，或者是套在了某一颗弹力球上。
So this then counts as an additional input. The cucumbers become sort of expert teachers of the neural network.
在这样的情况之下，小黄瓜就提供了额外的输入的资讯，而这些这个小黄瓜猪就变成了这个人工智慧系统的专家的老师。
So in the image itself, you can see the white halo around some of the balls. That is where the AI has detected contact between the tendril and the ball.
看到有一些的弹力球旁边出现了白色的光圈，也就是代表的是他们感测到了小黄瓜的触手触碰到了弹力球。
Next slide, please. So finally, I would like to share a bit about how these elements came together to make this neural network, to make this AI play with cucumber plants.
这些不同的元素最后呢，透过这样的算是跟这样的一个模式之后，建立成了一套神经网络，让人工智慧跟机器人可以和小黄瓜猪互动。
One of the biggest challenges, beside the fact that we are dealing with slow-growing plants and sparse data, was that I specifically didn't want to make a model of the plant.
当然，在这个过程当中，最大的挑战是我们在跟植物互动、植物的速度互动的情况之下，我并不想要打造出特定的植物模型。
And I also didn't want to make play into a game with set rules. I wanted to avoid imposing what the game, what the play should be like.
我也特意的避免，不希望让玩乐变成一种游戏，因为游戏的时候就代表你要加诸很多的规则，我不希望用规则去影响整个玩乐的过程。
So the first version of the AI was actually incredibly simple. So as a way of choosing not to define many things, we decided to use an autoencoder, which is basically just taking the latest image from the scanner, running it through this so-called latent space, which is an abstraction of all the memories of the previous cucumbers, and then basically acting upon this image that had been modified just through the previous experiences.
第一个版本的 AI 其实非常的相对而言非常的简单，我们使用这个自动编码器，然后他们透过了这个扫描仪所扫描出来的影像画面之后，去对比他们之前所知道的这些资讯之后，把它转化成最后跟植物之间互动的方式跟模式。
And when the cucumber is actually held onto a ball, we would say the ball should stop moving. So that way, through the process of play and as the cucumber grew, the degrees of freedom of the robots decreased.
在这个游戏当中的时候，这个 Z 就是 latent space， 就是代表的是这些植物的抽象记忆。而我们设定的基准是，如果这些触手触碰到了弹力球的时候，弹力球就要停止运作。所以等于说，当触手或者是植物变化还有触及的成分越多的时候，人工智慧所能够发挥的自由度就减少了。
And in the next version, which is, can you change the slide? Oh no, this one doesn't have the image. So I will just briefly explain it. So in the next version, we completely changed the AI, and this time it was given a lot more agency. It was actually, or it is choosing where to go explore this field of cucumbers. And it is actually the cucumber contacts that are teaching it how far to lower the balls, and the LiDAR scanner is informing another series of models to tell it where to go. So which areas are interesting, those areas where it's learning or forgetting the most. And that is sort of a simulation of curiosity. It is actively seeking out regions where it can learn something, basically. And the cucumbers are teaching it exactly where above or below the surface of the leaves, which it can see with the LiDAR, it has to lower the balls. So in a way, there's two complementary neural networks which sort of interact to make up for the very limited sensorium that the robot has. So actually, that is the end of of my presentation. So thank you very much.
这是第二个版本的人工智慧系统，它其实是透过这样的一个感测装置之后呢，我们让这个人工智慧有更多的主体性，他们可以自己透过这个升降弹力球的方式去探索哪些空间，而当每一次小黄瓜的触手触碰到弹力球的时候，就代表这个空间已经是到了极限，然后人工智慧透过不断尝试的情况之下，去知道哪些地方还是未知，还是探索，或者是有哪些还不知道的区域等等，它在参考这个光达扫描器所呈现出来的补充资讯之后，知道到底有哪些地方还有哪些多少的高度或多少的距离，还可以让它进行充分的尝试跟探索。所以这是一个反映出好像是人类好奇心的模式之后，让人工智慧跟小黄瓜之间植物之间有更多互动的方式。而这两种不同的神经网络互相互补之后，就呈现出最后今天在台北当代馆展出的这个 PLAI 的作品。谢谢。
谢谢 Špela，他精彩的分享。他的刚刚分享的东西让我开始想，就是我后面这棵植物它到底是现在在想什么，或者是怎么样的从他的观点去理解。
Thank you for the fascinating presentations. And during your talk, I actually started to think about the plants behind me and starting to think about what is he thinking and what is the world that he is understanding.
好，那我们下一位艺术家就是 Guy。
Now we shift the focus to Guy's work. Guy, the floor is yours.
Okay, can you guys hear me?
Yes.
Yeah. So thank you very much for inviting me. Thank you for all the people in MoCA, and thank you for Špela for a great talk.
非常感谢当代馆这次的邀请，也非常感谢刚才 Špela 的简报。
The title of my talk is called Surrogate Performer in the Age of In Vitro Intelligence. Surrogate Performer and In Vitro Intelligence are two new terms that we coined after completed the work cellF that I'm going to talk about today.
今天要各位介绍的这个主题叫做代理表演者，然后是在这个视管智慧时代下面的代理表演者。刚才提到的视管智慧跟代理表演者呢，这两个词都是我们在这一次展出作品完成之后所发明跟创造出来的新词汇。
It was the work self and the work after that we produced after self called bricolage that alluded us to the need to define those terms in order to discuss my work.
我们也在作品完成之后，因为在这样的研究之后，认为有这样的需求，必须要透过定义这两个新的词汇之后，才能够讨论我们今天产生的作品。
But I'll step back now and start with, the beginning, not jump to the end. So as you were kind of in the introduction, you heard that my name is Guy Ben-Ary and I'm an artist in resident in Symbiotica, the Center for Excellence in Biological Arts in the University of Western Australia.
各位刚才一开始听到主持人在介绍的时候都知道，我是来自于澳洲的在澳洲艺术家，在目前在西澳大学这个 Biosymbiotica 这个艺术卓越研究中心进行研究跟驻村。
And I'm interested in how art has, I would say, the potential to initiate a public debate, a dialogue on the challenges that arise from the existence of liminal lives that I create in the lab.
我希望能够透过艺术的方式来触发大家对于这个未来新科学跟新科技的讨论。那触发点呢，则是我透过实验室里面所创造出来的这个智慧或者是生命。
Self is one of those liminal lives.
细胞就是其中一种生命。
I usually create artworks that are designed to problematize current emergent biotechnology's influence on the shifting forces that govern and determine life, death, and sentience.
我常常会透过这些不同的艺术创作呢，去提出各种质疑，去了解这些现有还有新兴的生物科技到底如何去影响我们对于生死的定义。
So the idea is to problematize those technologies rather than celebrate them.
所以我希望透过作品来提出质疑。
Next slide, please. So this is a quote from Warren Katz, the director of Symbiotica, that I really like to start my presentations with, because it kind of sets the basis, some sort of a basic kind of thread to all my work. And I'll read it to you.
各位看到，这是我们西澳大学的这个研究中心的主任所写的一段话。我觉得这段话其实可以去贯穿我所有的各种不同的作品的概念跟想法，所以接下来会跟各位朗读出来。
The form and application of our newly acquired knowledge will be determined by the prevailing ideologies that develop and control technology. When the manipulation of life takes place in an atmosphere of conflict and profit-driven competition, the long-term results might be disquieting. One role that art can play is to suggest scenarios of worlds under construction and subvert technologies for the purpose of creating contestable objects. The role of art makes the emergence of the semi-living, or what I refer to as the liminal lives, as evocative art objects, and the multi-leveled exploration of their use relevant and important.
这边看到我们所熟知还获得的各种新科技的形式跟用途呢，其实都会受到很多的影响。那影响的来源呢，则是取决于我们如何透过什么样的意识形态来发展和掌控这些科技。当我们在运用还有去操控生命的时候呢，是为了要去追求获利或可能会影响冲突的时候，会产生冲突的时候，这些长期的结果呢，可能会令人非常的不安。那艺术在这过程里面可以产生的发挥的功能呢，则是要去呈现出这些正在繁衍跟正在发展上的世界，而且能够把科技的功能翻转过来之后，去创造出更多值得深思的问题。艺术的角色呢，是希望能够在过程里面去提出很多的挑衅、很多的质疑，或者是我说的这些透过这些小的生命的情况之下，去了解他们到底有什么样的探索空间，还有重要的功能。
Next slide, please.
下一页。
So In the last 20 years, I've produced many projects, or most of the projects that I produced included living neural network, biological neural networks that were used or acted as brains, quote unquote, of cybernetic entities that I created.
在我之前所创造的作品当中的时候，我都应用了很多的，比如说细胞的活的神经网络，或者是生物的神经网络，来作为所谓的大脑，然后通过这个大脑之后去控制这些网络还有科技的机器人。
The neural networks are grown, the cells, the neurons, are grown over specialized interface, as you can see in the image. 64 electrodes. I mean, this is it's a zoom into the dish, so you don't see the 64 electrodes. But there's 64 electrodes that the neurons are growing over.
各位看到，就这些的细胞跟神经元呢，它会特别的技术之后，在实验室里面发展跟培养。那在培养里面的时候，会看到他们会使用64个电极，这个是在显微镜里面放大的情况，所以看不到64个电极，但的确是通过64个电极的方式去发展出更多的细胞。
And those electrodes are a read and write interface. They allow us to listen to what the neurons are doing outside of the body when they're growing in the Petri dish, but also they allow us to stimulate back the neurons and tell them or inform them about events from the outside world.
这些电极呢，基本就是我们在培养皿里面的这个读写的系统。我们透过这个读写系统之后，去掌握这些神经元还有这些的细胞到底有什么样的讯息。同时，我们也可以透过这样的电极去传递很多外面的刺激跟资讯。
So there's two-way communication to and from the neurons.
所以这是我们跟神经元之间沟通的方式。
And an interesting question is whether the stimulations that we send the neural network through those electrodes would change the functional plasticity of this network to behave in a different way or to learn how to do particular things or tasks.
我们也好奇是透过这个电极去传导出各种的刺激之后，是不是会影响或者是塑造这些神经元去改变他们的行为，或者是学习某一种事情。
So when we grow those neurons on those interfaces, we basically grow what I refer to as external brains, those brains that are growing outside of the body with the potential of being emergent or maybe perhaps in the future when they're more complex to learn.
在这些的实验当中的时候，我都称之为这些在电极还有培养之下的神经元是所谓的体外大脑。那未来的话，也许经过发展之后，他们能够去学习更复杂的功能、更复杂的技能之后，他们也许能够有更多的功能，还有更多发挥的空间。
Next slide, please. So this is the dish where the electrodes are embedded in its bottom. And the neurons are growing over those electrodes within this Petri dish.
这是培养皿，那培养皿的底部呢，遍布了刚才提到的64个电极，那这些神经元就在这样的培养皿当中发展跟培育。
Next slide, please. So just before you start the video, this is a three-dimensional plot of 64 electrodes that are listening to the cells, to the neurons that are firing and communicating. And at one point, you can hear elevated activity, which is how the neurons respond to stimulations.
各位等一下看到的这个画面呢，其实是我们透过这个3D 立体的方式去呈现出64个电极，他们如何去接收这些神经元的互动跟反应。那有些情况的时候，它这个指数特别高的时候，代表是神经元接收到了电极所传达出来的刺激。
Please play the video. I can't hear the sound.
I don't hear either.
Is there any sound?
Not from my side.
Okay. Let's move on. So this is just a plot that shows kind of a neural activity over the multi-electrode array. And when there's sound, you can actually hear how they respond to the stimulations. Next slide.
当我们这样，如果听到声音的话，就听得到他们这些神经元是如何回应这些电极。
So in my artwork, in cellF, in other projects that I produced, what we did was to give bodies to those external brains, to these disembodied brains. We gave them a body in cellF. In various kind of other projects, it was robotic bodies. In cellF, it was a robotic body that focused on kind of producing sound.
在不同的实验跟作品当中的时候，我们都希望让这些所谓的体外大脑或神经元能够有个身体。那这个不同的身体、不同的功能，就会有不同的呈现跟现身的方式跟现形的方式。比如说，创造出不同的声响等等。
By giving those brains or disembodied brains a body, and to interact with, we could highlight the liveliness of those microscopic neural networks and manifest their erratic existence through movement, behavior, and also create a feedback loop.
因为有了这些的身体之后呢，我们就可以看到这些体外大脑其实就出现各种不同的变化，或者神经网络出现的这种变化，而他们的行为跟行动呢，就是我们可以互动的对象，进而产生一个这个资讯上面的循环。
Next slide. I just want to make sure that the terminology is right. We are growing neural networks, not brains, even though I use the word brains. Brains are three-dimensional organs, and they have trillions of neurons growing in a very specific way. The neural networks are made from 100,000 neurons, cells. And they're kind of in 2 dimensions. But however simple and symbolic they are, they do produce huge amounts of data. They respond to stimulations, and they're subject to lifespan.
各位在这边，我们要特别强调跟厘清的是，我们这次发展跟培养出来是所谓的神经网络。虽然我们使用是所谓的大脑去描述它，但它其实还是神经网络。毕竟大脑，我们人的大脑其实是一个3D 立体的一个非常复杂的结构，然后里面可能有上兆个或者是更多的这个神经元。而反观我们这次使用的神经的网络呢，其实里面大概有10万个细胞左右。它虽然看起来比较简单，然后也比较只是具有象征性的意涵，但是它还是会产生出非常大量的资料。这些的神经元跟神经网络也会回应到各种的刺激，而且它们也会有它的寿命存在。
And just to note that in the project that I'm developing right now, we're using organoids, which are the 3-dimension version of those neural networks. So we're growing mini brains that are quite small, but they're much closer to, or much better model to, kind of a human brain.
我们之前的作品里面，这些神经网络可能是2D 平面的，但我们现在新的发展的开发商的作品当中的时候，他们会变成3D 的神经网络。换言之，它是一个非常迷你版本的脑部，但是也会跟人的脑部之间更相近一些。
Next slide, please. So cellF and the incoming reality of in vitro intelligence. It's a collaborative project, it's important to say, that I developed with Nathan Thompson, Darren Moore, Andrew Fitch, artists, and Stuart Hodgetts, Douglas Backham, and Mike Adele that are scientists.
各位看到这次的作品，我们在当代馆呈现出来 cellF 这件作品呢，它希望你会去呈现出的是视管智慧的这个概念，就即将逐渐成型。那这个作品其实很多人合作起来的结果，它底下看到的这些的名字呢，包括了 Nathan Thompson、Andrew Fitch、Darren Moore 的这些都是艺术家，而下面3位呢 ，Stuart Hodgetts、Mike Adele 跟 Douglas Backham 这3位是科学家。
And cellF started with a grant that I got to develop my own biological self-portrait.
我希望能够透过这样的设计之后呢，去打造出我自己的生物自画像。
Next slide, please. And it started also with what could be seen as a materialist question underpinned by the belief that artistic practice can act as a vector for thought. What is the potential for artworks using biological and robotic technologies to evoke or elicit responses in regards to the shift in perceptions surrounding the understanding of life and the materiality of the human body.
这个作品一开始的时候，他们其实是希望能够提出一项问题去思考的是，到底艺术实践呢，能不能够去引发大家不同的思维的方式跟角度？也就是说，艺术作品它是不是运用了这些生物还有机器人的科技之后，可以去触发出各种的反应跟反思，还有回想，然后进而去了解我们到底现在对于所谓生命有什么样不同的看法，而对于人体的这个物质性又会有什么样的变化的想法。
Next slide, please. So what I did, I started by getting a biopsy. This image is kind of waiting in the waiting room in the hospital for the plastic surgeons to get me in. I wanted to harvest some skin cells of mine and to use stem cell technology called induced pluripotent stem cell technology to reprogram the skin cells into stem cells. So the first step into it was to actually get my skin cells.
这是我之前在医院的候诊室准备要做切片检查的的照片。那当时我在等外科医师，然后让我进去之后，可以从我的手臂上面切下的皮肤细胞作为这个当时发展跟培养的样本。那当时我使用这个技术叫做 iPSC 诱导多功能干细胞技术，然后透过这样的技术之后，能够让我的皮肤细胞变成干细胞。
Next slide, please. That's again in the plastic surgeon's clinic. You can see the little kind of wound in my hand. This is where they took the biopsy.
各位看到，这是当时在整形医师的诊所里面，各位看到我的手腕旁边有一道小的伤口，这个就是他们当时取出切片的地方。
Next slide, please. And that's the little biopsy that was taken out of my arm. This little piece of flesh, it's the mother of all my cells. Produced right now, I have probably 5 billion skin cells in the freezer and 5 billion stem cells and neural stem cells. A lot of bits and pieces of my cells are stored in a -80 freezer in liquid nitrogen, and all those cells originated from this little piece of meat that I took to the lab after the biopsy.
各位看到这培养皿里面这一小块的切片呢，就是我当时在诊所里面所拿到的切片。那这一片切片呢，就是我后来所培养出来所有各种不同细胞之母。那现在我可能有比如说50亿个皮肤细胞，然后50亿个干细胞，还有这些神经元细胞等等。大多数的细胞现在目前都储存在摄氏-80度的低温储存当中，或者液态氮储存当中。所以从这一小块的组织细胞，就让我培养出来我之后所开发出来各种作品的基础。
All those cells that I was kind of talking about are frozen in little vials. Each one of them contains 1 million cells.
那我刚才提到这些的不同的组织呢，都存在在这个不同的小的试管当中的时候，每一个小试管里面都有大概100万个细胞。
And it's interesting to kind of say that this process that I went through was kind of a pre-self process, because it was just about preparing my basic units or my materials for the work itself.
那这些都是前置作业，换言之，就是我当时只是为了要在培养细胞之前，先取出我的皮肤细胞组织。
It was kind of almost like the equivalent of a painter that goes to the shop to kind of select the materials for the work that they want to paint.
这就好像是画家或艺术家到美术材料行去买一些他准备要创作的材料跟素材一样。
Can you go to the next slide, please? So then I grew my skin cells in the lab, and I reprogrammed using this stem cell technology, induced pluripotent stem cell technology, to stem cells. And this image is of my stem cells that were growing in a Petri dish.
后来当然就在实验室里面把我的皮肤细胞透过这个 iPSC 的这个技术之后呢，让他们进行催化之后变成干细胞，而这就是我们当时在培养皿里面所看到的情况。
Those stem cells, once I had them, have the potential to differentiate to any other type of cell in the body.
当然有了干细胞之后，我之后就有可能把它发展出各种人体不同的细胞。
and I learned how to differentiate them into neurons. Next slide, please.
所以在下一页可以看到，其实他们在不同的方式把它分解成不同的神经元。
Next slide, please. Can you play this video? So those are my neurons. It's my own neurons that are differentiating and growing in a Petri dish. And you can see kind of in the middle and to the left side how there's like growth cones that are starting to kind of grow and create a network and to look for other kind of growth cones or axons and dendrites to kind of connect to and create synapses.
各位看到，这是在培养皿里面，我自己的神经元开始不断增生分裂，然后探索触及连结的情况。
So this is how those neural networks are formed in vitro outside of the body.
这是神经网络还神经元在试管中，就是在体外所分裂繁殖的情况。
And you can see how much more complex and busy, or kind of how much bigger the network is, kind of towards the end of the movie.
所以各位看到影片的前后，可以看到他们现在的神经网络变得更加复杂、更加扩张、更加的彼此连接的情况越来越多。
It's a time lapse that took 72 hours, so it's growth of 72 hours.
这其实是缩时摄影，所以这整个过程大概耗时72个小时。
Next slide, please. So then I learned how to grow those neural networks over the interface dishes, the multi-electrode arrays. And you can see here a dish with my own neurons growing on a multi-electrode array.
那后来，当然我刚才有提到，就是把这些神经元还有神经网络细胞呢，移植再到这个培养皿，然后上面布满了所谓的多电极阵列，然后进行培养。
Next slide, dish. And here's the multi-electrode array that is kind of placed in the kind of preamp that allows to extract the signals to the outside world.
这就是多电极阵列上面培养皿的情况，那可以透过这样的阵列设计之后呢，让他们可以传输外来的刺激。
And at that point, I started to think about the artwork itself. I mean, until now, it was all about understanding and learning how to use the technology and how to create those in vitro brains from my own stem cells.
在此之后，我才开始去思考这些艺术作品要如何去呈现跟成型。在这个步骤之前的时候，其实都要去学习的是到底要怎么样去培养自己的细胞，然后如何取出细胞之后发展出干细胞的系统跟神经网络。
Next slide, please. As you remember, I was thinking about creating my own biological self-portrait.
我刚才提到，我是希望透过这样的作品创造出我自己的生物自画像。
But after 2 years of looking at myself under the microscope, the last thing that I wanted to do is to create a self-portrait. I just couldn't look at myself again. So I decided to create to portraiture or to create some sort of a portraiture of one of my childhood dreams, which was to become a rock star.
但是我花了2年时间在显微镜里面一直看自己的细胞的时候呢，我决定不要做自己的自画像了，我决定要换一个角度来思考。我希望透过这样的呈现之后，能够呈现出一个不同的肖像，而这个肖像是我小时候的愿望。我小时候希望能够成为摇滚巨星。
And I decided to create my surrogate performer, self.
所以因此我就决定要去创造出这个所谓的代理表演者。
And that led me to the idea of embodying the neural network with sound-producing bodies, with an analog modular synthesizer that would act as an embodiment for those neural networks, those disembodied networks.
所以在这个情况之下，我帮这一个我所谓的体外大脑或者是神经网络所打造出来的身体呢，可以创造出声响出来。而创造出声响的管道呢，就是把这些神经网络跟所谓的类比模组合成器连接在一起。
Sorry, can you move one slide?
下一页，谢谢。
Next slide. So this is the modular analog synthesizers that I decided to work with. One of the reasons, there's a lot of reasons why we use them, some to do with kind of the aesthetic of the sound, and some to do with the kind of history of noise within kind of sound and art sound, and electrophysiology.
那之所以会选择最后使用这个类比模组合成器呢，是因为他们当时其实有很多跟过去声响啊、噪音啊等等不同的历史，然后我们也决定用这样的机器之后，作为这个神经网络能够去体现或现身在各位眼前的界面。
But one of the main reasons that we decided to use them, is that in a really surprising way, and I'm oversimplifying it, they work in a very similar way to neural networks. There's control voltage that goes between components to create sound. Within the neural networks, it's microvolts that are going between the neurites, the axons, and the dendrites. And in the analog modular synthesizers, it's control voltages that goes between the modules.
所以其实我当时这边是用非常简化的方式来说明为什么会使用类比模组合成器呢？是因为它们其实运作的方式跟神经元跟神经网络之间有很多的相似性。那在这个类比模组合成器的当中的时候，他们使用是透过电压来创造出各种刺激之后，进而去产生声响。而这些的神经网络，他们在互相沟通的时候，其实也会创造出很多的微电压，然后传递讯息。
So we realized that we can actually juxtapose or connect those two components, the analog modular synthesizers and the neural networks, and to create one network that goes between them. So the electric signals goes from the neural networks, from the neurites, and flows through the neural network, through the interface to the modular analog synthesizers. And there's nothing in between. We didn't need computers. We didn't need translators. The signal just goes between the micro to the macro in one go.
所以在这种情况之下，我们设计出的这套系统呢，其实就非常有意思的把这个神经网络跟这个类比模组合成器并置在一起之后，把它串联在一起之后呢，这个所谓的电极或者是微电压从神经网络传递出去之后呢，就可以直接进入到这个类比模组合成器，然后直接去进行电压的刺激之后，进发出声音。所以过程里面这两者之间直接相接之后，不需要透过任何的电脑或转译器，就能够直接让神经网络系统发出声音。
So next slide, please. So in itself, there's no computers, there's no programming, there's no translation. It's 100% analog and wet-analog components. There's two networks are juxtaposed to create one big network that goes from the micro volts in the neural network to the macro to the analog modular synthesizers to create sound.
所以在过程里面再次强调，他们其中不需要用到电脑，不需要用到程式，也不需要转译器，完全是100%的类比跟湿式类比之间相连在一起。所以在这个神经网络当中的微电压，它就可以直接传导到这个模组合成器之后，进而在模组合成器发出声响。
Next slide, please. So with cellF, as you remember, I wanted to create a performer, a surrogate performer, not a musical instrument. So we created an interface where we invite human musicians to play with cellF. The interface allows the human music to be streamed into the neurons as stimulations. The neurons respond to the stimulations and control the analog modular synthesizers that produce a sound. And therefore, we create a feedback loop between the human musician and the neural network. We create human, non-human communication between the performers, the two performers, one of which is a human musician, and the other are neural networks that are growing in a petri dish.
这边看到我们当时这个 cell 的这个打造的概念，就是我们让这一个人经网络跟合成器连接在一起之后，他们可以发出声音。那这些神经网络所受的刺激来自于哪里呢？我们就邀请了一名的人类音乐家、人类乐手，当他去敲击乐器或者是发出音乐声响的时候，就可以被转化成刺激，去刺激这个神经网络。而神经网络发出的这个电受到刺激之后发出的微电压，再传导到了合成模组器之后呢，它能够发出声响，而这声响能够呼应到这个人类乐手所发出来的乐声，所以这种情况之下，就形成了一个这个资讯的流通网络，在人跟非人的音乐创作者之间产生互动跟沟通。
Next slide, please. That's how cellF looks when it performs. It was performing in Sydney.
这是当时这个设计装置在雪梨所呈现跟表演的情况。
Next slide, please. It's a close-up on the neural interface of self. At the top there, the kind of bright square rectangular. That's where the incubator is and the cells are performing live.
这是看到特写镜头当中的时候，下面前方的是模组合成器，而后方那个透明的方盒子里面就是培养皿，还有神经元，就是所谓的体外大脑。
Next slide, please. And that's self-performing with a cello player, Okyong Lee, in MONA, the Museum of Old and New in Tasmania, Hobart.
各位看到，这是当时跟大提琴家他们在合奏的，还有互动的情况。
It was one of our better shows. It was quite really unbelievable.
所以当时这个作品在 MONA 呈现出来的时候，其实我觉得非常的令人惊艳，我认为觉得非常不可思议。
Next slide, please. So, self represents an interesting and provocative move away from artificial intelligence inquiries that dominate our current technology-focused scientific discourse. It is not an AI musical robot driven by computer algorithms. At the same time, it lacks the complexity of natural intelligence and requires a hardware body to provide stimulation for its in vitro brain.
所以各位看到，其实这一次的设计非常的有趣，因为它并不是完全，它并不是人工智慧，它其实是来自于神经元所产生的这些智慧。在这种情况之下，他们就跟人工智慧跟自然智慧之间有一个很奇妙的空缺，或者是彼此之间的相连，然后呈现出来的在试管里面所培养出来的智慧。
So if it's not an artificial intelligence-driven entity, but it's also not a natural intelligence-driven entity, it falls into a taxonomic void. In the absence of terminology that adequately accounts for self's autonomy and plasticity, and its capacity to make music or duet with human musicians, self is best understood as an entity possessing in vitro intelligence.
在这种情况之下，这个作品 self 呢，它既不是人工智慧所驱动出来的的作品跟表演，也不是从自然智慧所驱动出来的产生跟表演，但它能够去透过这个模组合成器，然后去产生声响，或者是能够跟音乐家、演奏者一起组合配对呈现表演的话，我们认为在这种情况之下，没有一个适合的名词可以来形容这样的概念。既然它是从试管里面所发展出来的这个神经网络，我们就称之为试管智慧。
An intelligent system produced by bioengineered living neural networks that function as brains outside of the body. We grant that self represents a very early form of in vitro intelligence, symbolic in a way, yet the characteristics of its neural network suggest that it or others like it may demonstrate changes in functional plasticity in the future, just like intelligent entities do.
在这样的情况之下，虽然这是我们在透过生物智慧跟生物技术跟生物科技所在实验室里面发展出来的一套系统，它虽然非常的相对而言比较简单，规模比较小，然后只是具有象征性的意涵，但它其实可以预示跟去呈现出来的，在未来如果我们在继续发展这套的神经网络的时候，它会有更多的可塑性，也许会有更多功能的变化之后，去创造出各种所谓这些试管智慧所能够达到跟发挥的效果。
Next slide, please. And another slide. So, as we kind of said, self is driven by in vitro intelligence. Self is a disembodied biological performer. So, what I was going to say, self is driven by in vitro intelligence, but it's also a disembodied biological performer. It is both the creator and the creation of an ongoing real-time cellular performance of what we refer to as a surrogate performer.
在这个作品 cell 当中的时候 ，cell 它既是一个所谓的这个神经元的网络跟神经系统，它同时也是一个没有身体的生物表演者。它在过程里面，它其实不断的即时在透过细胞的展现跟展演之后产生出声响，所以这个即时的细胞的运作跟即时运作出来的声响呢，就是我们所谓的代理表演者。
Self is my surrogate performer. It is biologically linked to me because I gave self, or I gave it, I gave my cells that were then reprogrammed to become its kind of in vitro intelligence or its kind of brain. But it's autonomous once it's on stage and starts playing with other human musicians.
当然，一开始 cell 的这个原来的这个细胞呢，组织其实来自于我，所以所以这次的作品里面 cell 是我的代理演出者。但是它一旦发展出了自己的神经网络系统，或者是开始跟其他的演出者表演合作的时候，他们就这个作品或者这个神经网络就产生了自己的自主性跟主体性。
And as a speculation or provocation, we wrote this in a paper. It was part of a book, The Future of Music. We envision a future post-corporal connection between body, instruments, space, and time, where creative production tools cease to be divorced from the biological body. Instead, artist and artwork are one in the same. The complexities and nuances that these prepared living entities can embody will give rise to a new kind of performative entity, an entity physically removed from the human, but linked through lead-based processes in which biopsied material grown outside of the donor's body in vitro control a creative hybridized entity or specifically a surrogate performer.
我们后来也把这些的研究呢发表在一本跟音乐有关的书籍当中，那里面提到的是，我们希望在未来的这种连结呢，去创造出了这些后人类或后人体的这些连结，包括了身体、乐器、空间跟时间等等。在这种情况之下呢，我们可以看到这些新的艺术家跟艺术作品，他们其实是结合在一起的。它既是艺术家，也是艺术作品。在这些活的这个实体当中的时候，它其实非常的复杂，也非常的细微跟细致，产生出了很多新形态的表演。那这些表演呢，其实并虽然说它已经跳脱了原来的人体，但是他们还是跟人体所相关的这些实验的过程很有关系，而且这些的神经网络或这些的这个演出的实体，其实还是来自于本来人体所切片下来的组织。那在这个的试管的培养之后呢，就创造出一种新的混合式的实体，也就是所谓的代理表演者。
Now I'm aware that my time is over, but I just want to show one more slide. Next slide, please. And I won't spend too much time of it, but this is important because it's another example of a surrogate performer. This is the new project that I'm currently working with Nathan Thompson and Stuart Hodgetts.
那各位看到，这是我们目前正在进行的新的计划，一样是跟 Nathan Thompson 这位艺术家一起合作。那这个作品对我们来说格外重要。
The idea in this project is to immortalize Alvin Lucier. Alvin Lucier was one of the greatest composers of the 20th century, and his career spent between the 1960s until last year. On December 1st, he passed away.
各位看到我们这个作品叫做 Alvin Lucier 不朽的过程。那这个 Alvin Lucier 呢，是其实20世纪非常重要的作曲家。那这位作曲家的作品从1960年代一直到去年他过世为止，其实都有非常重要的作品。
And currently, Alvin, we worked with Alvin 2 years prior his sadly before he died, and we obtained his. He gave us his cells, and we are currently growing his organoids, mini brain organoids in the lab, and we're going to hopefully use them to create a project that would immortalize him. We would. We're working towards creating a project where he will play in a museum. We hope to install this work permanently in the museum, whereas Alvin's surrogate performer is going to perform forever, indefinitely, continuously into the future, and would continue to create art continue to compose, to tell new stories within the museum through his surrogate performer and after his death.
在这位作曲家他过世之前，我们其实已经跟他合作了2年的时间，他非常慷慨的提供他的细胞，我们现在正在实验室里面去透过不同的流程跟制作方式之后呢，发展出这个他的神经网络或者他的所谓的类器官或他的迷你大脑。我们希望最终呢，他的这件作品可以装置、可以常设或者永久放在或呈现在美术馆当中。这样的情况之下，所以 Alvin Lucier 他的身份或他的创作可以变得不朽，他的这个所谓的代理表演者就可以不断的、永远的在美术馆里面创造新的音乐，然后为大家演出。
And I think that I'll stop here. Thank you very much.
好，我的介绍到此结束，谢谢。
谢谢 谢谢 Ben-Ary 的分享，然后也谢谢 Špela 的分享。那个我代替大家就是谢谢你们。然后我们接下来是进到 Q&A 的阶段。
So thank you both for your presentations. I'm really amazed and I'm amazed and fascinated by both of your works. And now I think we can move on to Q&A sessions. If anyone from the audience have any questions, please feel free.
那我们在脸书上已经有一位观众有留言，那他是想要问Guy Ben-Ary， 就是我在这边把他的留言已经显示在荧幕上面了，所以我还是念一下就是他的问题。他说根据生物学定义 tumor 就是 abnormal growth of tissue 就是不正常组织的生长，那么我们是不是可以称就是 Guy 的这个作品 cellF 是 tumor 的 noise 会想这样问是因为好奇，第一个有关科学名词跟艺术叙事之间的拿捏有没有什么看法或者是伦理，因为艺术家本人也强调不是 brain 而是 neural tissue。 那第二个是这个 neural tissue 的 input 到 output 的过程可以称为一种有意识的演奏吗？类似行为主义跟功能主义所提倡的。
So this is a question from our viewer, and Frank Hu is asking that biologically, tumors is an abnormal growth of tissues. So in that sense, can you describe cellF as a tumor's noise? I would like to ask this question because is there any kind of perspective between scientific terms and artistic narratives? Because you also emphasize that this is a neural networks, it's not a brain. And also, he would like to ask that in this neural networks or neural tissues, from the input to output, do you think is a kind of conscious performance?
Well, I don't think that it wasn't a tumor. You know, I mean, it was those were cells that were taken from my arm, and they were healthy cells, and you know, that went through some sort of a biological alchemy, some sort of a journey. That way, it was reprogrammed from skin cells to neural networks. So I don't think that there was any. I don't think that they were tumor cells. But can you repeat the question again?
He was asking, like, is there any kind of ethical issues you're thinking about between scientific terms and efforts and artistic narratives as well?
Well, you know, I mean, there are, of course, that there are ethical issues to do with the work. First of all, the idea of growing brains outside of the body is a very scary one. You know, it's a very problematic prospect. And as I said, cellF is there not to celebrate this technology, but it's to problematize it by putting a contestable future. So, you know, I mean, we're kind of putting some sort of a scenario, a contestable idea on the table, and we're kind of bringing it to the gallery, and we're saying, you know, here we created a surrogate performer. Here, there's the potential of generation of in vitro intelligence. Let's think about kind of the ethics that is involved in that. Should we go down this path? Should we try and create intelligence outside? And this is kind of also to do with artificial intelligence. You know, I mean, there's a lot of there's a problem with the idea of are attempts of growing or kind of creating intelligence outside of the body. Whether it's happening or not, it's a different question, but art is positioned very well to discuss those problems in a sense of bringing them into the gallery, bringing them into, or kind of adding them to some sort of a dialogue, and kind of not leaving it kind of in this on kind of unknown or untalked about or undiscussed about. This is exactly why we're doing it, you know. I hope that I answered the question.
各位刚才看到的这个问题呢，他觉得他这个东西应该不能称之为所谓肿瘤噪音，因为毕竟这个细胞是从他身上取下来，当时是非常健康的细胞，所以它并不是比如说异常生长的组织，所以这种情况下应该不会是所谓的肿瘤。但是这样问的话，当然其实道德或伦理上面的议题或争议，毕竟我们是在把这些细胞从人体取出之后，在体外去发展出所谓的大脑或者是所谓的智慧等等。这种情况之下，我们创造出这个艺术作品，并不是要去歌颂这些现有的生物科技或技术，而是要去提出很多的质疑。我们告诉各位，是这样的情况是可能发生的，那是不是要往这条路继续走？或这些事情是不是人类希望看到的，这是另外一件事情了。但是艺术的功能是希望能够透过在艺廊的呈现之后，让大家知道这个潜在问题或潜在的可能性的存在之后，进而可以激发更多的讨论。所以当然并不是为了要透过这样的过程告诉大家未来的方向应该这样走，而是告诉各位在这样的现在科技的发展之下，有可能会出现这样的情况，有可能未来会有体外的这些智慧或者是视管智慧的呈现跟出现。The second question from this audience is about, is this input-output process from the neural tissues can be called or described as a conscious performance?
No, I don't think that it's conscious at all. We're far from understanding how consciousness is created or where is the threshold for intelligence and consciousness. But it's our way of creating a feedback loop between the neural network and the outside world.
我并不觉得这是一种有意识的演奏，因为毕竟我们现在对于意识，所谓到底的那个意识的门槛是什么，其实还没有个非常明确的定论。但是我的确认为，在这样的过程里面，我们创造出来的一个资讯上面的回圈，然后透过这个回圈之后呢，让这个资讯可以进而流通还有传递。
But I think that also the fact that this person asked about consciousness and is concerned about it means that, you know, what we're trying to do here is kind of working, because it's bringing into the table the possibilities of creation of consciousness in the future. Perhaps, maybe we will never get there because, you know, between us, we don't really know how the brain works.
但是这个问题现在这位观众会提出来，这某一个程度代表是我们这个作品继续发挥它的功能，因为让大家会开始好奇、想象、怀疑、质疑，是不是会有意识的存在？也许我们未来会有可能因此产生出，会创造出意识，但是这也是我们未来还不知道的事情。可是我们透过这样的讨论之后，可以大家开始去思考，到底人类希不希望去创造出人体以外的意识？
谢谢 Guy 的回答。那我这边我想要再往下去，就是根据这位听众的提问，还有刚刚 Guy 的回答来去做一个延伸的问题。就是刚刚有提到说Guy 的作品其实就是想要去problematize 这些 biotechnology， 就是去显示出这些 biotechnology 它可能会带来的一些问题，那可能很多时候是一些伦理上的问题。那所以我还蛮好奇，就是说，就是像刚刚这位听众提到的问题，就是它其实就是一个展现说这样的一个作品确实是发挥它的作用。但我想问的是说，就是想要邀请Guy再往下去分享说，就是因为某一些人在看到这个作品的时候，他可能会觉得说，哇，太酷了，这种科技居然可以就是带给我们这样子的一个作用，像是可以当做我就是没办法实现梦想的一个代理人。那又或者是说我可以去就是一个很棒的艺术家，他就算过世了，我们还是可以就是让他就是继续创作下去。那所以我还蛮想请Guy再多说一点，就是说关于这个 problematize biotechnology， 他会觉得怎么样子去往下做，可以能够更深入的邀请大家去思考这些问题。
So follow up on these questions. I think that, as you mentioned before, when we see questions like this, it means that this work actually works, because you problematize biotechnologies and show you the potential issues or potential ethical problems or situation that you may encounter with this developments in biotechnologies. But I would also like to extend from that, because that for some people, when they see the work like this, they will be fascinated. They may be thinking that, wow, it's cool, it's so nice that in the future we can immortalize these great artists and musicians forever and ever. So I would like to know that from this, how would you continue on your inspiration and artistic process to raise other issues related to these technologies?
Well, I mean, it's a big question. I don't know. I mean, I just do my work. And I create works that I'm interested in, and I mean, it's I don't really plan it. I just kind of get hooked into things, and I go into rabbit holes, and then I find myself doing stuff. But I think that it's very important for artists like Špela and myself and other artists that are working with technology, whether it's biological technology or whether it's artificial intelligence, to be very critical about the work, to try and understand where are the problems, to try and understand where are the ethical issues that are attached to it, to try and kind of be independent from kind of profit mechanisms or from kind of commercial or corporate agendas, and to really try and portray those questions or to portray those scenarios in a very honest kind of way, and then get the public to engage as much as possible.
当然这是非常大的问题。那我并不一定在一开始的时候就已经先预想好要怎么样去发展了。我常常一开始的时候是对于某一个事情感到兴趣，然后开始着迷之后就开始进行研究，进而创造出作品。那创造出作品的过程里面呢，其实不论是我或者是 Špela 今天两位艺术家，或者是其他的艺术家，在运用这些科技、生物科技或者是人工智慧的时候，我们都必须要去不断的保持这个批判性的眼光跟角度，然后我们必须要独立于这些商业牟利的机制，然后进而去让大家去注意到跟看到这些潜在的问题，在科技发展之下可能会呈现出来的问题。那我们的作品希望能够发展出这样的功能，跟出现出这样的一个角度，让大家看到我们看起来非常目眩神迷或者看起来很酷的科技，其实会有一些潜在的道德争议或者是伦理的问题存在。
好，谢谢 Guy 的回应。那我们下一位是听众的留言，其实不是听众，而是我们的策展人孙以真。那他的问题是想要针对 Špela 的分享。那他问说，艺术家是不是觉得用植物的速度、植物的时间感去培养出来的 AI， 会和目前常见训练方式养成的 AI 有很根本上的不同？同时也好奇作品执行至今，关于和植物一直玩所培养出来的 AI 有什么心得可以跟大家分享吗？谢谢。
So this question is from our curators. She's asking Špela this question. Do you think that the AI that you have developed that follow the planned time and planned speed is different from typical AI that we see in the market? For example, what are the differences? And also that since this AI have been playing with plants, are there any particular feature or characteristics that you can tell us about?
Mm-hmm. Yeah, thanks. It's a very interesting question. So the motivation for making this AI wasn't to really literally have an AI be designed by plants, because finally we have to remember that it is humans that are writing the program, people that are putting the cucumbers in relation with this robot that was designed for them. Therefore, the significant difference is in our desire, in this case, my desire that manifests this AI program that aims to play with cucumber plants rather than optimize their growth habits or produce more cucumbers. So I wouldn't necessarily try to take the human out of this equation and say that this AI was written by cucumbers. What I'm trying to do here is to redirect the urgency and redirect the end goal of the use of AI from something that is utilitarian, such as the AI that is usually used in agriculture, to something that is used for an intensification of the relationship with the non-humans. I probably should pause for the translation here.
好，我们这一个作品的动机并不是要去打造出一个 AI 是由植物所打造或者设计出来的 AI， 毕竟这个整个作品其实还是很充满了人工的色彩，有很多的人为的这个行为在里面。比如说，这个制作其实是我们人的程式，然后人的设计、人的装置跟安装之后呈现出来的这样的情况。所以 AI 跟植物之间的关系其实是由我们所打造的。所以这次我认为我这个作品当中跟一般的 AI 之间的差别是人的欲望不一样。一般的时候，人们用的 AI 可能是为了要去提高它的产量，提高它的这个产能啊、收成更好等等。但是我的欲望是希望让这个 AI 可以跟植物开始玩。所以这是一个欲望上的不同，所以导致出不同的结果。那这样的情况之下，我们看到这个 AI 的差别就会跟一般 AI 的结果不一样的差别，是因为我们的目的并不是功能性的，而是采取这种就是希望能够连接跟创造出AI 跟植物之间的互动。
But I also wanted to add that working with plants, questions about consciousness and intelligence become less important because we simply do not know. And the consequences of what it means to treat plants as beings that have full agency and full freedom of making decisions, or as passive subjects. What are the consequences of thinking of them in one way or another? That becomes, I would say, much more significant. So I like the concept of play because we are trying to achieve it within the epistemology of science. And play is actually outside of that epistemology. So there's finally, whether you see play, whether the plant is teaching the algorithm or not, whether it's just simply reacting to the situation, really at the end comes to your positioning, your conviction. Do you choose to see this as play or do you dismiss it? And I actually really appreciate that.
在过程当中，我们其实当然没有办法去厘清到底这些植物有没有它的意识去跟这个 AI 玩。那因为毕竟我们当然没办法去判断到底植物的意识何在与否，但是它会影响到我们到底要怎么样看待这件事情。你的角度到底是你认为这个植物是有主体性的，它有自己主动的角色，在这个过程里面去跟 AI 玩乐，或者是它依然在你眼中是一个被动，只是在这边生长的这个植物等等。这个其实最重要的是取决于我们人对于这件事的看法。所以那至于你怎么样去看待这件事情的时候，这个后果还有这个后续的影响的效益是我觉得更值得讨论跟更值得好奇跟研究的。所以我其实更想要去探究跟了解的是，当我们去透过玩乐，这是一个没有规则非常自主自发性的这个过程的时候，到底我们看到这个植物跟 AI 之间它产生了什么样的所谓的互动，或者是这些不同的关系的呈现出来。
And finally, I would just like to add, similar to what Guy was saying, this project is actually a challenge to us thinking about AI itself. It's about challenging what we can envision AI of doing. Because if it is just about performing representations of intelligence that we already know, we will get something, very restricted. Is there a possibility to employ this tool towards something else?
这个作品就像刚才盖所说的一样，我们是要提出一项挑战跟质疑，就是这些人工智慧到底未来的发展是什么？如果我们都把它运用在现在已知的领域的时候，其实最后的结果会非常的有限。但是如果我们能够跳出这些已知的框架之后，去探索这些另类的，也许不同于一般常理的这些模式的时候，会不会为这个人工智慧产生出不一样的可能性或不一样的发展？这个是这一次这件作品希望能够去挑战跟提出的问题。
谢谢 Špela 的回应。那下一个是同样 Frank 想要问关于我怎么样子来看待，就是 Špela 在 play 这个作品的一个前提，就是假设万物，就是他这边在谈主要是植物都会玩耍的相关看法。那我觉得在这边就是我不打算直接回应这个问题，反而是针对这个问题，我想要对 Špela 提一个提问。那我觉得那个提问就是其实就是我对于就是他的作品关于玩耍这个看法的一个观点这样子。那所以我的提问是就是关于玩耍这件事情，或者是甚至在Špela 从就是刚刚分享一开始提到的各种 project， 其实很多时候都似乎是围绕着一个很核心的一个概念，是就是不是从人为中心，而是变成是以植物为中心这样子的一个想法来去贯穿其实里面很多的作品。然后我很喜欢那个就是里面提到那个 lip， 就是那个作品根本就记不起来那个作品名字，根本记不起来那个作品。那他其实就是在挑战说，当我们今天在从人为中心、人的角度去理解这些事情的时候，它的局限是什么？然后邀请我们试着去从像是植物的观点来去理解事情。但我这边还蛮好奇一件事情是说，就是像是提到从植物的角度，或者是甚至提到 play， 我觉得似乎都预设了一个就是要有一个植物的观点这件事情。但我觉得这个东西其实很难设想，像你可以设想说，我从像我家的一只狗，它的观点是什么样子，或者是你的朋友，或者是现在像我去设想说 Špela 或者是 Guy 的观点是什么样子，然后从他们的观点来去理解说他们现在可能感觉如何，或者他们在想什么样的内容。但是要想说从植物的观点，我觉得是一个很微妙的一个状况，它可能会需要包含就是要么就是它可能要有意识。有感觉，就是对作为他感觉起来是什么样子，又或者是说从他的不一定要有可能不一定要有意识预设有意识，可能是说从他的角度来去理解说，对他来说怎么样是好，怎么样是不好，就是从他的角度来去判断价值等等的。所以我觉得似乎都预设一个就是从植物的 perspective， 就是这个观点这个东西。那所以我还蛮好奇说 Špela 怎么样去看这件事情，还有包含是说他在发想、在设计，甚至在创作的过程当中，他都怎么样子去想象这个东西，就是在一个植物的观点这样的东西，这样子的一个就是想象是什么样子去进行的。
This question is from the common participants, actually directed to Professor Lin, our moderator today, but she would like to redirect that question to Špela because that she's interested in your works. In the presentation, you talk about your previous work. I particularly like that one that the Institute for Inconspicuous Language really lips, because it shows that AI doesn't even work because it cannot read lips out of context. And I think in most of your works, you also imply that we want to jump out of the human-centric perspective. We want to think from a plant-centric perspective. How will these plants feel or make judgments or make values? But I think it's relatively more difficult for people to assume or imagine this kind of perspective, because like when you look at your dogs, when you look at your friends, you may start to put yourself in their shoes and try to understand what is their perspective, how would they see things. So I would like to know, how do you imagine that plant perspective when you design these artworks?
Yeah, that's a sort of like a tricky thing to speak about, because much of my experience has been, very visceral. It's hard to articulate this intuition, so to speak. But on the other hand, we have recently gotten a whole body of scientific study by people like Monica Gagliano, who is a plant scientist from Australia, actually, or she works in Australia, who stopped asking herself how plants could do this or that by comparing plants to animals who have a brain, who have a heart, who have, I don't know, limbs that move around. And rather, she just posed situations to them where they could express things like making decisions or learning, associative learning, and so forth. That, for me, is something that I really am inspired by. To not think about what it is that, or how a plant would perceive certain impulses, what it's like to be a plant, but rather seeking situations where plants can express themselves. And perhaps, if I am lucky, I am able to recognize that is that expression. But again, it's all very subjective. I am, however, encouraging this type of enchantment because I feel like it can generate other intensities of relationships that exist today.
那其实这个问题对我来说，当然要回答也有点微妙，因为它很多时候这个的想法是出自于我的内心深处，是一个我很直觉的想法，很难就非常清楚的去言说什么样的方式让我去想象这些植物的想法跟观点。那有一位在澳洲进行研究的这个学者叫做 Monica Gagliano， 他其实在描述的是一般人都在想象的，比如说如果植物是像动物一样，它有四肢、有触手、有感官、有眼睛、嘴巴的时候，他们会有什么样的反应，或他们会有什么样的行为。但是与其用这种观点来看待植物，他们现在这个学者在设想的是，如果我们把植物放在某一种情境当中，然后让植物能够表达的话，那会是什么样子？那我也其实深受这样的概念去启发，所以我非常鼓励大家，虽然这是一个非常主观的念头跟想法，但其实这是个非常有意思的想法。因为如果我们把这些植物放在某些情境当中的时候，它们可以开始表达，而我们能够观察到或者是感知到这些表达的时候，这就是我们可以去重新看待我们跟植物的关系，或者是我们跟这个世界上其他物体或物件的关系。
谢谢 Špela 的回答。我想要分享一本书，就是叫做Plant Mind， 它是一个哲学家写的书。那他其实就是在谈说，他觉得就是他有点像是脱离我觉得他比较像刚刚提到那种就是类似功能论的观点，就是去看说，我们一般在理解 mind 的时候，mind 可能都有具备哪一些功能上的面向，然后他就是试图去用一个最 minimal 的方式去谈这些mind 的面向，然后再去植物上去分析说这些我们认为像mind 需要具备知觉，需要具备怎么样子一个认知，需要具备记忆，需要具备就是能够行动等等的这些面向，然后他就往植物身上去分析，然后发现说这些面向的植物都有。
I just want to share the book. It's called Plant Minds. It's a book that focuses on the mind and how you can understand and perceive the minds, because like when you analyze the minds, people have certain criteria. For example, you need to have perception, you may need to have memories, and you may need to be able to take actions. And when this author used a very minimalist perspective and way to place those criteria on plants, actually it all applies to plants. So in that regards, actually there are minds in those plants.
Okay, so 时间差不多了，那我们今天的活动就进行到这边。那再一次宣传一下，就是我们这次就是2位艺术家会就参展的这个展览共视觉，一直到1月29号。然后所以如果就是大家想要看作品的，就是 作品本人，其实是影片，就是影片的介绍，然后甚至听到那个 cellF 的创作，然后看那个 Špela 他们的就是整个那个创作历程完整的影片的话，那在1月29号之前都可以到 MoCA 去看。那在这边，不好意思，你先翻。
Thank you, everyone, for this sessions. I think the time is up. Once again, the artwork that we have talked about today are exhibited in MoCA until January 29th. So if you're interested or if you're curious after listening to this sessions and you want to take a look, you have the opportunities in MoCA Taipei until January 29th to see their works and how their works are presented in the exhibition.
那最后我们再谢谢，就是我们的2位艺术家 Guy 跟 Špela 的分享。
Once again, thank you, Guy, and thank you, Špela, for your time with us today.
也谢谢各位观众。那下次我们有机会再见。
We'll see you next time online. Thank you. Bye bye.
Bye bye.